Okay, thank you. Yeah, welcome everybody. So I'm here to show you how you can level up your machine monitoring game. As she said, if you have any questions, we can do that afterwards, or you can come by our booth over there. So I can show you live the system, how it's working, and we can answer your questions. My name is Gerhard, and I'll be your host during this journey, and which will take you all the way from sensors on the plant floor into enterprise applications and even beyond. So what's the agenda of today? So I start with a quick introduction of Opto 22, who we are, what we do, and how we've been focused on simplifying automation and connections and connectivity for decades. We talk about the state of machine monitoring, why it matters right now, and how you and your customers can start leveling up in practical ways, really. And then I walk you through a real-world example. We look at how a tier one supplier approached machine monitoring, what challenges they were facing and how they solved them. And I want you to leave this session a concrete picture of what's possible and what is practical, really. And finally, I will wrap up with the next steps, how you can start small, what's achievable at a fair cost, and where to go if you want to learn more and put that into practice. If you haven't heard about us, Opto 22, we are a California-based, privately held enterprise, a manufacturer of industrial automation, hardware and software. We have over 5 decades of experience with an installed base in the millions and thousands of customers all over the globe, and we are known for highly reliable mission-critical products that backed by a lifetime warranty. Just last year, we celebrated our 50 years anniversary, still privately held, so we're pretty proud about that. But what really makes us unique is our engineering philosophy for combining rugged, reliable OT systems with open IT technology into affordable, versatile products that save you time, money, and effort. This is a drone shot of our headquarters in Temecula, California. That's where all of our products are designed, developed, manufactured, and supported at this factory in Temecula, California. It's about 1 hour north of San Diego. And with all that out of our way, let's get started. Now, maybe I'm biased because this is what we do at Opto 22 day in and day out, but to me, it's pretty obvious. We all know clipboards and spreadsheets aren't the answer anymore for machine monitoring. We all know that our customers want real-time view of what's happening. They want to eliminate errors in manual logging and reporting, and in doing so, we know we can optimize the workflows and get better output from our production lines. The bigger question is, what does moving past that really looks like? And from a practical standpoint, how can we help you and your customers actually move past antiquated and inefficient systems? The key isn't just replacing the paper, it's finding practical ways to bring more equipment, more real-world measurement, and more information into the digital conversations. And once you do that, monitoring stops being a nice to have and becomes a foundation for more reliable and more autonomous and more efficient future. And of course, it starts with the fundamentals, part counts, runtime, vibration, temperature, energy use, and flows or whatever, So those numbers matter, they always will. They help you plan and schedule, optimize performance, spot failures before they occur, and ultimately prevent costly unplanned downtime. But it's not just about monitoring, it's about doing it in the right way. If all we do is, just bolt sensors and spin up another disconnected digital system, we've just traded paper for a different kind of mess, really. So the right way is making sure the data is structured, it's consistent, and ready to be used anywhere it is needed. On the plant floor, in SCADA, in OEE, in MES, ERP, and potentially even in AI. So if you're developing a greenfield application, this is easy, lucky you. So you aren't dealing with all the legacy systems, so you can build from the ground up, choosing a platform that, has flexible IOs, that connects to any kind of sensor or actuators, programmability that matches your style and preference, anything from custom C programs to Python, JavaScript, to traditional ladder logic and function blocks diagrams that are part of the IEC 61131 PLC programming standards. Protocol support, you can look for open protocols like OPCOA, MQTT, Sparkplug, even simple REST APIs, whichever fits your organization's digital strategy. But also tools that still having the cybersecurity features that IT departments will love, like zero trust authentication, TLS support with security certificates, onboard firewall, multi-zone networking, and even VPN for remote access. And if you are, an Ignition SCADA user, we, at the application I'll show you later, they use Ignition as their SCADA, then you will love, that we support your favorite SCADA system right on the development platform. So you're filling it to the ecosystem in various ways, from running Ignition Edge on board of our devices to publishing data in an on-prem or even cloud gateway. But Alice, we live in a brownfield world. Not everything is greenfield. So here's so many teams that are stuck, because you might recognize that man, Al Nipper, he's the co-inventor of MQTT. He's a SCADA guy, just like most of us, with decades of experience solving the same problems we deal with every day. You all know this struggle, and I know, firsthand, many of our customers, they do as well. So there's equipment out there running, producing, and adding value day in and day out that is not even connected, There's no networking available. Sometimes not even a PLC, just manual controls. Or if there's smart control in an existing machine, many of them are older legacy controllers with no network access. Or we all have seen this one. You have a modern PLC inside of your machine, some sort of, but the system data is locked behind some vendor's custom control programming, and you can't touch it really. And of course, if you manage to get signals, that might be tagged like XYZ, LMNOP 123 or whatever, it might be difficult to figure out what that means, Probably won't include engineering units, any context, so it still doesn't mean anything to you. So this is where you're left, Most of our customers, of your customers, haven't even solved the basics, and they can't even tell if their proverbial refrigerator is running. So this is reality, and we see that all of the time. So I think I proved my point, we need data. We are missing data. Data is missing the missing piece of the puzzle, really, So these bullets represent the ultimate goal for data. We need to connect, collect, store, visualize, and analyze everything, And we know that there's plenty of technology available to do that, no doubt about that. But remember, we can't really complete the puzzle if the piece we need is locked away behind a black box. So make sure to choose hardware platforms that are built on an open and flexible technology stack, not part of a closed architecture that might look like an easy decision, but on the surface, but they will lock you out for life, So the puzzle begins to get solved when we make that data usable across the organization, perhaps even outside the organization in some cases, so wherever is needed. So that's the foundation that can help you and your customers level up and start incorporating more advanced analytics, and of course, even our benevolent, overlord AI in the future. So even technology institutes, they agree with us, AI is not plug and play. So it requires systemic change processes, culture, workflows, and in some cases, the entire way your organization operates. And yes, that kind of change introduces friction, especially in established firms that are already a lot of have legacy systems. This is why we are not seeing the big productivity gains from AI currently. Just remember that before we can get to machine learning, smart factories, industrial LLMs, predictive everything, digital twins, and all of the other cool stuff, we need visibility. So I think everyone agrees with that, and I think I've proved my point before. So now you're wondering, how do I get all this brownfield data from all those legacy machines and all of these well-established firms, into enterprise applications to help my customer level up their digital foundation? So I'm here to tell you this is actually cheap and pretty easy. And if you don't believe me, I will share a customer example, in just a few minutes. I'm going to share you a story of how an inexpensive little edge device can bolt right into your legacy machines to help you connect to existing machines and sensors directly without needing an expensive PLC upgrade, so you can collect production data without touching or rebuild the control logic, store the data by publishing open structured data via MQTT, Spark-Plug-B, or expose that data using other modern interfaces like OPC-UA or even REST API. And it's all simple and configurable with built-in tools into the system, into the device, while still providing, best-in-case cybersecurity that you need using TLS encryption, user access, and control that, user access control. That's all what your IT department really will love. And of course, for visualization and analyzing, it fully supports any kind of SCADA system through either OPC-UA or MQTT. So you can really securely publish from the edge device into a central gateway on-prem or even in the cloud using an onboard MQTT publisher. So this architecture shows how that is built up. So enough theory, so let's dive into the real world now. Moriroko Technology North America, in short MTNA, is a great example of a high-performance manufacturer with a lot of legacy complexity. Let's take a closer look. They are a tier 1 supplier in the automotive space with 4 plants across the US and Canada where they produce plastic parts that end up on vehicle dashboards, on body components, all kind of trim and spoilers. And after COVID pandemic hit, various supply chain challenges exposed some weaknesses in their inventory tracking and reporting. I don't think anyone was immune to this. I know we certainly felt the same of it in our own manufacturing operation. So it led MTNA's management to launch something that they called their Vision 2030 initiative. So the goal was to achieve better visibility into what's actually happening on the plant floor and to see everything in one place in a single screen. For MTNA, it made sense to start at the heart of their operation, the high-precision injection molding machines. And they've got a lot of them, But for MTNA engineers, unifying data from over 100 machines over 4 different facilities into a single unified namespace seemed to be impossible. And this is a great example of a customer who came in with a big picture goal, and we helped them to build the digital infrastructure to get there. So let's get into the nitty-gritty here. So before we got into the solution, let's look at what they were up against. It was the classic dark asset problem. Each site had 20 to 30 different injection molding machines. And since each facility came to MTNA through acquisition, and nothing was a standard really. So machines were manufactured by different companies, had various control systems in them, and supported different communication protocols, if any. And so standardizing data collection didn't even seem possible for them. And for the reason everything was done by hand. So now look, it's an obvious problem that, to point out when you literally have operations writing down machine status and batch results every 15 minutes or so manually, it's not if you are going to make a mistake, it's more of when it's going to happen. On top of that, even without mistakes, there are delays in visibility. Production reporting could be delayed for a myriad of reasons. And if something went wrong, engineers and plant managers would only find out after the fact. And of course, by then it was too late to prevent something or, have any downtime scenarios. Ripping, replacing every machine's control just didn't make sense because these are valuable production assets, and forget about, the cost of a new PLC for downtime itself. To retrofit legacy machines would be more costly than adding another solution. So they need a flexible bolt-on solution here. And their engineers were smart. They made the decision early on to develop their Vision 2030 around a modern IoT technology stack to follow a unified namespace architecture, UNS architecture, building on MQTT, Spark-Plug-B, publish, subscribe communications. But there's an important piece that I want to remember. MTNA didn't start with 100 machines. They didn't start even with 10. They started with one single machine. They grabbed the Raspberry Pi, something inexpensive, easy to program, perfect for proving out a concept. And sure enough, it worked, So they showed without significant downtime, they could tap into live signals of a molding machine and publish the data into an MQTT broker. In this case, it was Ignition's MQTT distributor module, that they were using as the broker. And that alone was a huge win. The message here is, this is the same opportunity for all of us here. You don't need to top-down initiatives or with a massive budget, to get started. You can start small, a single board PC, single IOs on a single machine with a single instance of software running there. But I do have another message at that place. Cheap and easy isn't always sustainable. The Raspberry Pi was fine for the lab, but once you start thinking about 100 machines across multiple sites, the model really falls apart. So I've seen people a lot with Raspberry Pis, and I love them myself. But when it comes to the point, to the plant floor, there's so many issues. You've got to maintain an operating system in them. You patch IT, keep the security alive. In MTNA's case, they didn't have the option for analog IOs, which was important, for some water flow measurements that they needed to do at the injection molding machines. And ultimately, it's not industrial grade, to survive the harsh environment found on the factory floor. So the lesson is twofold. Start small, try things, learn. But when you're ready to scale, move to industrial grade tools that can handle the real world demands of manufacturing. And that's what MTNA did, So when it was time to build a pilot for production, they searched for a device that checked the following boxes: industrial grade plug and play flexible IO, built-in MQTT, a spark plug B engine, secure, efficient, published data where it was needed on change. And by the way, for those that are familiar with MQTT, who think it's only a good solution for remote assets, remember there's a lot of benefits outside saving bandwidth when using MQTT. It decouples the data producers from the data consumers. It reduces polling noise and CPU load. And of course, it helps to build a really scalable architecture or a scalable data model for the plant floor. It needed to be affordable enough to scale across the entire enterprise. And that quote here from Jeremy Johnson from MTNA on the right, it sums it up. Ultimately, they needed something that could bring everything together without making things more complicated. They wanted to capture signals that mattered: full auto mode, mold changes, water flow, open-close cycles, simple signals, but very crucial for tracking cycle time and machine availability on injection molding machines. And ideally, they wanted to do this in a universal way without complicated bills of materials. So even if one machine used 4 to 20 inputs and the other one 0 to 10, they could still use that system. And if you could do all that in a single device, you can scale that up to 100 machines easily across the different facilities. So they selected our Groove Rio system. I have 5 minutes left for Q&A. Can I just continue? We do the Q&A over there, so I just have a few things to tell. So let's look at the first one. So how easy it is to get this done, machine by machine. So this is the basic setup. Each injection molding machine has a Groove Rio installed nearby, typically in the existing electrical cabinet. And then we're tapping into a few existing signals from the machine with configurable software selectable I/O that capture the key metrics, things like mold ID, cycle status, and water flow. And these critical data points, are enough for MTNA to know how the machine is running. Once the Rio were installed and wired up, MTNA commissioned each unit. Each device is completely web-based, so commissioning is done in a browser with simple menu buttons to get the areas where you need to configure. Here you can see MTNA's setup, appropriate administrative accounts, account access, network, and security. Everything is form-based. You just check some boxes, fill in a few form fields, and you're ready to go. Next is they configure the I/O points. Here's where they named the I/O points, and which, by the way, is the single source of truth for the tech throughout the whole ecosystem. So the name you use here will be shown in your complete ecosystem. So here's where they set up other parameters like scaling, engineering units, and again, just fill out the forms, check some boxes, and you're ready to go. From there, they configured the MQTT in the same way to publish tags to a broker. In MTA's case, the MQTT distributor module from Ignition was their broker that they used. And now you're publishing. So the whole overview for machine one, they tapped into existing signals for the machine. They commissioned it to be a cyber-secure citizen on their network, configure the I/O channels, and started publishing. So, and it didn't require them to write a single line of code or even touch the original control system. A fully bolt-on, scalable machine monitoring solution for their UNS architecture. That's what one machine looks like. Now here's what the full rollout became. Rinse and repeat. They just look at the same architecture and scale it across a couple of dozen machines at each of their 4 factories. Each plant has its own set of machines, and each machine has its own RIO publishing directly into an on-prem ignition gateway. In those gateways, they model the data to organize it into UDTs, universal data types, again, providing details for accurate context like location, work cell number, engineering units, and so on. And the value is, the value in using UDTs is that now each machine's data is in the same format as its next door neighbor. So even if they have completely different control platforms running the process, they all look the same. From there, all the data flows into centralized an ignition instance in this case, could be any other SCADA system, which is running on Azure Cloud, which provides the real-time visibility across the entire company. So the last part handled using the gateway network, which you can see here. Now they have digital foundation to move forward, analytics, reporting, and other parts of their Vision 2030 plan. Isn't that beautiful? So the data from multiple assets is flowing into one structured namespace in the UNS. So what did they ever deliver for MTNA? Well, of course, they ditched their clipboards, not needed with a system that reports in real time. Beautiful ignition dashboards like this on the right on the plant floor, give stakeholders across the business real-time access to production metrics down the second across all machines. By seeing what's happening in real time, they can now catch problems sooner, keep cycle times consistent, and avoid delays. And of course, with their UNS architecture, they now have a great foundation for what's next, including potential AI applications. Here's we can see real-time cycles of their machines. So they've been able to capture now, visualize all the metrics and around the machine utilization. Each row is a machine. Green means the machine is running, and red shows a cycle timeout, and purple marks that there's a mold change currently. Here's another great example of data that they show target versus actual count, cycle times, downtime, scrap in real time. This is the kind of visibility you get once you have your machines all connected and feeding real usable contextualized data into. It is what looks like across multiple machines, a full inline view, not just a one-off. Each machine performance can be compared side by side. You can instantly spot where you're ahead, where you're falling behind, and where downtime or shortages are holding you back. Here's the full plant view you saw before on the TV in their plant. Every machine on one screen, and in seconds you can tell what's going on. Perhaps just as important in their Vision 2030 is, are they ready for what's next? So they've already exploring possibilities of expanding their machine monitoring initiative into their paint lines, conveyor systems, and vision-guided system for quality control. In summary, there you have it. Today's established manufacturers are facing the same problem, lack of visibility. The solution is affordable, edge monitoring. The proof is in the pudding. 100+ machines connected at MTNA and unified namespace architecture ready for what's next, a rock-solid application. What's next for you? Getting started doesn't have to be complicated. We offer free training, free support, and free application engineering, helping you to make sure that you can do the same thing. You don't need to figure it out all yourself. We are, part of a community, and we can help you with that. If you want to have more information, come by to our booth over there, and I can show it you in live. Thank you. Sorry, went over time a little bit.